Hi, my name is Brian McCarson. I'm a senior principal engineer with Intel Corporation. I work in Intel's Internet of Things group in the Strategy and Technology Office, and I'm Intel's senior architect for our end-to-end horizontal solutions within the Internet of Things. And what I'm going to describe for you today is how you can connect devices into the cloud using a methodology that promotes scalability, interoperability, and security all the way from the edge to the cloud across your entire IoT solution. So in the IoT universe, you've got the things portion of the universe where you've got a variety of sensors deployed in smart homes, smart automobiles, and actuators in some circumstances as well, in smart factories. And these sensors are sending data. And this data needs to be transmitted into a cloud environment. But transmission of that data isn't always simple. It needs to be secure, and it needs to be done in a way that promotes interoperability across a variety of network, OT, and IT infrastructure. So there's a few ways you can achieve that. One is by having a gateway solution, and this gateway device serves multiple functions. One function is it provides you security to lock down the edge of the Internet of Things. And there's a variety of ways that it accomplishes this. One is using an Intel gateway product, you can have the silicon itself be the source of security. So you have both hardware and software level protection to lock down your edge device. And you can achieve that through a variety of methods, but some of the most prominent features that are very important in the Internet of Things is having this immutable hardware identification, having this hard-coded ID that's unique to every device so that you know exactly what device you're supposed to be talking to. And having that hardware level ID combined with a functionality called Secure Boot, where every time the device boots up, it checks itself compared to a known good image to make sure that nothing has gone wrong with that device and the device hasn't been tampered with. An additional feature that you can have in your edge devices is the capability of having whitelisting. So every device is going to have a number of different agents that run on that device. And those agents are going to be specific to your application, and you don't want someone else to be able to download their agents on top of your device. So by having a whitelist, you're able to say specifically what are the agents that you want running on your device, and nothing else is allowed to run. So this provides you with an extra layer of protection when you're trying to control your edge devices. Now, as these edge devices are coming online, they're going to need to communicate with the cloud and understand from the cloud's perspective, is this the right device I should be talking to? And Intel's IoT solutions offer additional protection as well in that space, and that protection actually gives you a manageability and ease of use benefit as well. And that's achieved because in the state where you have a hardware ID that is known, so when the device boots up, you're making sure that it goes through its secure boot sequence. Only the agents that are supposed to be running on that device are actually loaded and operating. And the device can say, hello world, I'm here. This is my hardware identification. I'm ready to get to work. And if that device, through your security infrastructure, is on the list of known friends that you have in your metadata catalog, this device can basically say, I was expecting to have this ID from device A, device B, but device C is not something I'm supposed to be working with. It's not on my friends list, so I'm not going to allow that device to come onto my network. So this is a way that you can let the device itself automatically provision itself into the cloud and start getting to work right away. And this metadata catalog capability, along with the security features that we provide, enable that. So it's the combination of hardware and software level security that really gives you that security strength. And this can be then managed through security policies, through remote device management as well. So you can have your devices, once they come online, they say, hello world, I'm here. The network says, aha, I was expecting you, let's get to work. You can, over the air, send updates from your data center back to your edge device through your remote device management capability, and have over-the-air updates that tell this device, these are the exact things I'm expecting you to do. So you can push new agents onto that device, the latest security policies, without having to send a technician out to the field to reflash one of those devices. So in the world of things, you have all these different sensors that are collecting data, and they're transmitting that data towards your cloud through an Intel-based gateway solution. And those sensors are sending information with a variety of different languages. You could have language A, language B, language C, language D. And this gateway needs to be able to process that information and turn that information into actions. In the case of where you want to send feedback to an actuator for something like a smart factory, and that enables you to have real-time and closed-loop control for Internet of Things solutions for environments where that's critical. But all these different languages make it difficult for information to be ingested into the cloud. And what Intel's able to provide is protocol abstraction. So we have, in this case, 4 different protocols that are communicating to a gateway, but the gateway will be able to abstract away or normalize out all that variation in the languages that the devices are speaking through protocol abstraction, and then be able to transmit information using some industry standard protocol. It could be MQTT, DDS, XMPP, CoAP, whatever. Using an open industry standard protocol protects you from having to deal with all the variation in both legacy and new implementations of the Internet of Things where all these different languages are being spoken. As these devices are communicating, though, across different market segments, there's different requirements for what sort of communications technologies are going to be critical for the particular deployment that you're interested in. For example, in one scenario, using Wi-Fi communication may be ideal, but that same deployment will not work. In another application, you might need something much more powerful over a longer distance, like 3G or 4G. And Intel understands that you're not going to be able to have one wireless communication technology work for all solutions. There is no one-size-fits-all. So you need to have these gateway devices capable of listening to a variety of different protocols and communicating over a variety of different comms technologies. So having a broad distribution of comms technology capabilities across those solutions is critical as well. Now, with all of this information, you're able to do a couple of things. You're able to have scalable compute. If you start off your solution thinking, I just have some simple amount of information that I need to process, my compute requirements may be relatively low, you can have a very efficient, low-powered gateway solution that can handle that level of compute very cost-effectively. But if over time your needs change, you realize that you want to add video analytics capabilities to an existing IoT deployment, having a scalable compute solution means that you can take out of that gateway one standard, lower power, more efficient device and continue to upgrade along the power and performance curve until you get just the right level of compute that you're looking for. And over time, you can change that, and by using one solution for compute capabilities, it prevents you from having to continuously update your policies and your overall infrastructure because you can just simply socket out one solution and put in a different power performance envelope product for specifically what you're looking for. So having a wide array of compute capabilities from low power efficient devices to very high performance devices gives you scalability in your compute performance that allows you the flexibility to change and modify and improve your IoT solution for your needs as those needs change over time without having very expensive overall infrastructure changes. Additionally, having compute capability at the edge with the gateway product enables you to have the appropriate amount of compute necessary to perform any analytics that would be required specifically for your edge application. So your edge compute enables you to have broad edge analytics capability because the compute is exactly where you need it for the kind of analysis that you need for the kind of information you're trying to extract from your Internet of Things solution. So in addition to having compute scalability at the edge, having scalable compute in the data center is critical as well. And by moving it into the data center, it allows you in some cases to have the efficiency and the economy of scale of letting most of your compute functions be performed there and only what's needed at the edge. So having scalable compute solutions that have the right size and scale of power and performance for the needs of your Internet of Things deployment in the edge provides you with a lot of additional capabilities. And all this compute capability enables you to perform big data analytics for your Internet of Things solutions so that you can have the same information you collected at the edge for a particular deployment expanded across an entire worldwide fleet of assets. You can turn this basic data into information that can become valuable insights into how your Internet of Things solutions are functioning in the field, and so you can extract the value that you're hoping to achieve from your Internet of Things deployment through that analytics capability. Additionally, in the cloud, you have the capability of adding a wide array of API library and API management capabilities through Mashery services, and this gives you the opportunity to open up your IoT solution to third-party developers so that they can use your secure network infrastructure, your secure edge devices, and access some of the value that's coming out of your Internet of Things solution, and do that in a way that allows third-party developers to build value on top of your deployment in ways that we may not even be able to think of. And additionally, an Intel-based gateway that utilizes some of the edge management capabilities that Wind River offers can allow you to make sure that you can remotely manage those devices that are being deployed in the field and make sure that they're functioning properly. So as your Intel-based gateway is functioning in the field where it's deployed for whatever market segment you're using it in, there's additional security capabilities that you can add in as well. Intel's able, through our McAfee software, to be able to monitor how all your devices are performing and look for abnormalities. Look for cases where an edge node is streaming a large volume of data much more than usual. Look for multiple attempts to contact the cloud from one particular IP address. And it can sense these abnormalities and use that information to try to protect your Internet of Things solution while the devices are actually in operation.